Everyone is here, and we have Patricia. Back.
I have been asked to do 2 talks back to back. I've done them before. Both times they were 45-minute talks. So you're going to get a short version of one and a fast version of the other. So the first talk I have is about learning C++ if you're coming from a Java background. So first of all, does anyone have a Java background? One person, yay, 2, oh, 7 more people. Okay, and does anyone have, like as a C++ programmer, have you had colleagues that came from a Java background? Yay. Okay, because I think this talk is relevant both if you are learning C++, but also if you are teaching C++. And I think most of us will end up in a position where we will teach somebody who's new. And so this is a talk that is about that. Now, the reason why he has a funny face is that's kind of a face that we all kind of make sometimes, programming C++. But I think it's probably even worse if you're coming from Java. So I'm going to be very fast through the intro. I'm a programmer. I program mainly in C++. I've been doing it for around 12 years. I've worked several places, but I used to work on the Opera browser. Any Opera browser users at any point in time? Thank you. Okay, yes. Now I work on the Vivaldi browser. It's from one of the same founders of Opera. So I brought some stuff, but you should try our browser. It's cool, and it gets better all the time. Okay, so moving on. So this is going to be a mishmash of modern C++ mostly, and normal older C++. And I'm not going to tell you when. So this is the first thing for any Java programmer. This is really hard. And it is really hard because it's so close. This is what a Java programmer will do if nobody tells them anything differently. They will know everything. And that is because that is what you do in Java. You knew everything. The only difference here, if you're coming from Java, is you have to put this like weird star over there. But besides that, looks perfectly acceptable. So if you're going to like teach them anything, then this should be like the first thing you teach them. Don't do this. And I would actually go to the point where I'm saying, if you're coming from a Java background, don't ever know anything. Because I think that's a good place to start. It's sort of like if you're going to practice being good at the keyboard, take away the mouse. This is the same way. Just say, you can't do this. Now program. So go forth and do stuff. So this is the most important slide in the entire presentation. I'll repeat it for emphasis. OK, so this is how we're going to be making our objects. And it's telling people this is an object is hard. Because if you're coming from a Java background, this is a pointer. It by default, it points to null. And this is what they see when they see that. It looks like Java, and it is a pointer in their mind. So for them to get to the point where they're realizing that this is an actual object, it has been allocated, a default constructor has been called, and it is allocated on the stack. It's like, whoo-hoo, that's like, they don't think like that. So this is the central point of making them understand how memory is allocated. So you come to dealing with libraries. And they're used to dealing with the standard library coming from Java, but they're not used to necessarily our type of standard library, which is highly optimized for performance rather than necessarily always usability. Sorry. But so basically just this gives an example of a very small program and how you do printf, or no, a system out print line, which is their version down there. So distinguishing between how you include headers and what that means is often a thing that is very confusing when you come from a Java background. Sometimes things are included with the quotes, and sometimes they're included with the brackets. And there are actual differences between those two and how you use them. So your own headers you do with the quotes in your own project. Your library headers you generally do with the brackets. Some will not necessarily heed this. But is this normal practice in your projects? Yes. Okay. Okay, in Java you have a concept of packages, and that's how you scope your names. They're generally called package com something something at the top. And this is packages in C++. We call them namespaces. And I have here my hero class inside of the namespace league. And so I can make heroes by actually specifying the namespace in front. So it's a league : hero. That is the hero class that's inside of the namespace league. But I can just also open up the namespace league. And in Java, that is called a static import. They can also do that by breaking up a package and importing all the names. And they call that a static import. Okay, so, and then you end up in this. I made this presentation for a Java conference, by the way. So I was trying to bring them over to the dark side. Yes, so here you have opening up the std namespace. Okay. Then this is the second part that is really hard if you're coming from Java, is the concept of values. Now there are thinking about it for Java 10, but still they have no concept of that anything can be a value. And trying to explain that is kind of difficult. I think the easiest way to make them realize it is that they have to understand memory. They have to understand how the memory thing works, because that is kind of abstract. But also to say that things behaves like a basic type like int. But this sounds very weird to a Java programmer, that a hero is like an int, that everything is a value. And what does value mean? It becomes very abstract. So that is something we're going to look at a little bit. But first, we're going to look at how we reference things. And the first thing is that a Java pointer is something they're going to bring with them. And they're going to try to figure out how a Java pointer is in C++. But we don't have anything like a Java pointer in C++, and that is very important that they understand. So first of all, a C++ reference is not a Java pointer. It has to reference an object. It is never null. It can never reference another object. I know there are caveats to many of the slides, but just ignore them. This is the general rule, okay? It should be true. And then we do that with the ampersand. This is one thing that I try to teach, that you shouldn't have pointers. Because pointers in C++ are not a Java pointer. They're very unsafe. That's why we prefix them often with calling them a raw pointer. It is a raw memory address, and so it is not something to take lightly. If you have a pointer to raw memory, it's often you're often in an unsafe situation. And then you have values. Now this is very strange for someone coming from Java, because you always pass objects by pointer everywhere. And so here, having the concept of being able to pass a hero object into a function, what does that even mean? That is something that has to be explained. That there is copying going on. Either actual copying, or sometimes we optimize away the copying, but in the abstract, we are always doing copying. And that you can copy arbitrarily large things. You can pass big things as parameters, and they will be copied. And this behavior as a value is something that is very difficult to grasp. And then I just want to reassure them that we do have range-based fors, and they're all right. You know, we're not all in the 90s. And then there's Kunst. We have two words in C++, which is just, there's a lot of, and Kunst is not the worst. I mean, static is the worst. I'll get to it. But but this is a very strange thing for Java programmers to see, because they do have something similar. They have something they call final. And I'll skip back a little bit, but let's see here. they have the first one here. You can say like a final hero, and remember this is a pointer, not an object. In this case, the pointer is final, so you can't set it to point to something else later. That's their syntax. That's what they're coming from. That's all they have. It's not, there's no more. You can have like final on classes and members and things like that, and that behaves like const on in C++, but on reference of pointer typey things, they can only actually make the pointer const. So explaining that you can have a non-const pointer to a const object is very difficult to understand. What does a const object mean? And the last one there is just because it's always the funny thing of people have to decide where the second const goes, because that's, people can have in C++ the funniest discussions that can go on for ages, and that is one of them. So I have heard at least 20-minute conversations about where that const can be. But it can be on both sides of it, yeah, okay. Anyway, so if you're going to explain it, they like the concept of immutability is very much in vogue in Java and also in other languages. So to try to explain the concept of a const object as being an immutable view of an object. So here you're passing a reference to a const object. So you can get the object. This is the actual object. This is the real one. But you can't modify it. You can look at it. You can peek at it. You can do whatever you want. You can do anything that is const. And this concept doesn't exist in Java, so it's difficult to you don't have, because generally what you do when you learn a new programming language is you're trying to map it to something that you know already. And if you have nothing to map it to, that's kind of that learning model breaks down. So they don't have anything to map it to, so they kind of have to just learn this and learn that it is a good thing. Okay. So in this case, you can call canFly. That's perfectly fine because canFly is const, and this you can only call const functions on this hero object. But fly is non-const, so you can't. So this is not going to compile. Okay. Then we come to parameter passing return values and lambdas, because we have lambdas, because we're modern. Okay, and this picture is fabulous, by the way, because they're passing the spaghetti. See? Okay, thank you. I just needed to point it out. Okay, so then it's like, how are we going to be passing stuff? I would say, and this is, I had lots of discussions on the CPP Lang Slack with people about, like, because this is a very opinionated talk, I'm basically saying what I think you should do, and it's like, and that's very dangerous territory in C++. But I think it's opinionated because I'm trying to kind of like point them in a direction that is relatively safe and is a good place to start as having a good default. So I would say after consensus and talking around people that most people consider passing by const ref to be the best. Is that a general consensus here as well? Yes. And if you have to modify, then passing just by ref is all right. People are still generally okay with that. And people are getting to the point where it's like, values are all right. It's not so bad. Kind of depends. People are warming to the idea of passing by value with the whole move semantics thing. It's kind of like growing on people. So like the whole value thing, I think we'll get more of it, just a little bit. Passing by pointer, I said be very careful because that became very controversial. Because I basically said don't pass by pointer. Because you shouldn't have any pointers, because where did you get that pointer? I mean, you didn't know anything. So where is this pointer coming from? But anyway, so I would say to a Java programmer to try not to pass by pointer. Oh, and then you have the auto return type. They don't have auto yet, as far as I know. In Java, no, there's no auto in Java. And we already have them on the return type. is cool. And in C++ 11, you don't have to do the weird pointer thing either. That is it. That is valid C++ right there. That looks like JavaScript. Okay, so then you have return by value. And this used to be a very controversial subject. It is getting less controversial. And the reason why it's getting less controversial is that there has been slowly but surely being optimizations being done to remove the copy. And now it has been made mandatory in C++ 17. Yeah? So this is a good thing to know because this is quite a nice way to do it. And it's very simple code. So in this case, you're returning an unnamed value. And this will be moved. Here you're returning a named value, and it's getting a little bit iffy, but it's still going to be moved if you're not being dumb about it and doing all sorts of weird stuff. It's still going to be moved. And these fabulous optimizations. The first one is Arvo, because we make the best three-letter things. It's just like, yeah. But then we realized we had another one, and then we had to put an N Arvo. But basically, if you have an unnamed value, it is going to be moved when you return it. This goes under the whole move semantics. That's a whole thing, but think of it as you don't make a copy. Because in theory, in your head, in your theoretical model, in your head, it's going to be copied. This hurts people who are working in C++ because we don't like that. Not anything that takes too much more time or more memory or more anything, we don't like it. So this is to make all the C++ people feel better. The Java person generally won't feel bad here. Because they're doing stuff all over the place. And it's like, and the garbage collector comes and fixes everything, and it's all right. So this is actually just something that makes us feel better and them more confused. So you might actually skip this part. Slicing. Now this is very confusing, and previous speaker talked about it a little bit, but it is very confusing coming from Java, because this kind of concept can't occur. So what happens in slicing is basically here you have what I call a subclass, and C++ people generally call it a derived class, right? That adds a field, current altitude, because it's a flying hero, and we need to know how high, right? And so we make a flying hero. Here we have a Superman. And then we're going to copy Superman into H. But a hero doesn't have current altitude. Superman has a current altitude, but when we are copying him into H, he loses his altitude. And he's no longer Superman. He's a generic hero. This is not easy to understand, because for a Java programmer, they can do this all the time. Like you have a derived class, you set a pointer back to the pointers. Yeah, we can do that in C++ too, but they should not have pointers. So they'll end up in this kind of weird situation. And sometimes you'll end up there without even thinking, like with exception handling. It's a very common problem too. It's just something that people do without thinking. So it's something that is important to teach, and it also teaches them a little bit about how to think about the memory of their objects as actually being a section of memory with like bits in it. It's not an abstract concept. It is actually memory there. Because that is how C++ people think about memory. We think of it as something we handle and deal with. Whereas in the Java world, it is an abstract concept where you kind of throw out objects into it and something. Oh, this is cool. Did you guys know that you can do this? I mean, come on, C++ is becoming so cool. Okay, okay. So here you have a function point. It returns a tuple of 2 ints. Then you can and I don't know the right word for it. From some languages, you would call it unpacking.
Structured binding.
Destructure the binding.
Structured binding.
Yeah, the whole thing is called structured binding. But what do you call this process?
Decompose.
Decomposing?
I think so.
Destructure. See, I don't know the word, but it is cool. Okay, so this is like this thing returns an X and a Y, you know, in this tuple thingy, and then you just poof, right in there, and there, those are.
Which I recently learned. What's the type of X?
The type of X is int, as far as I understand.
Yeah.
Both of them are ints. Here?
It's int reference. Super strange. Because really what is happening is that you're getting the tuple back, which is a temporary that you don't see. And then it gives you two references, one X going to one int and the Y going to the other int. So these are references into a tuple that you don't see. And so if you write below return X, say this is not an int but something more complicated, you actually have to write return std move X if you want to move. Because it's not a value, it's a reference. Yes, it is the most.
But oh no, okay, we're not going to go there. No, we're not going to go into move semantics. Okay, moving on. See, that is like the other talk. That's 20 minutes. The move semantics, that's 2 hours. Okay, lambdas. A lot of people who used to program C++ get really surprised when they realize that C++ has suddenly gotten lambdas. Like, where did that come from? It was like, and this is just basically just describing the syntax and what it looks like, because that is something that varies a lot from different kinds of languages. That you have the capture over there, and that it will capture copy or here by default and here by reference. Like, it's just trying to explain how it looks like, because the thing is, most people coming from other languages have lambdas. This is not new to them. So you just say we have a lambdas in C++, and they're like, oh, okay, what does the syntax look like? And they're fine. So this is like, it's like we have stuff that we think is like are going to be easy, and they find hard. This is something that many C++ programs think will be hard, and they will think is no problem. Sure, no problem. That's how the lambdas look like. Okay, so then we're going to look at memory, because this is the most important thing, actually. And especially the concept of handling lifetimes, because that's not something that C++ programmers have really, now Java programmers ever thought about. So basically, they have to start thinking about that things can live on the stack and things can live in the heap. And that the way that we have evolved C++ is into a culture of using the stack to manage the lifetime of heap objects. But not only, like right now I'm talking about memory only, but the whole resource allocation initialization model is for all types of resources, right? But some of those they can handle a little bit because they have introduced some syntax for it in Java, but not this. So you have a hero here. He lives on the stack. He is a stack hero. Here, down here, you have a heap hero. He was allocated with new, so he's going to go on the heap, and that's where he's going to live. These two don't, this is on the stack, this is on the heap. That is kind of difficult to understand. And then we introduce this, and this is how I'm going to tell you. You can't do this, you have to do this. There's no new there. But this hero still lives on the heap. But this hero here has a unique pointer on the stack. So explaining this to Java programmers is saying that it's similar to try with resources. They have a thing in Java. It's really cool. They say like try, and you can put in a parenthesis the kinds of objects that you want to have an automatically, I don't remember what, they have a close method? Closable, the closable interface. And so when they go out of the try block, the close method will be called automatically. So try to explain that it's sort of like that, except for like a close method, the structure will be, you know. just called automatically when they exit scope. So it is very similar to this. They actually have, the problem is they only have it in like that one situation. But we can say any scope can work like that in C++. And it's a way of giving mapping back again to their mental model. Yeah, so things are destroyed when they exit their scope, and then their destructor is called automatically. You don't have to think about it. Or as C++ developers like to call it, deterministic garbage collection. Okay. Or as one guy on Twitter said, GC happens there at the curly bracket. But basically, yeah, you have a string here. It's allocated on the stack. When it exits the scope, its destructor will be called when it hits the curly bracket. This idea of having a value on the stack and then using that to control the lifetime of a heap allocated object it takes a little while to get used to. And the picture here is she is allocated on the heap, but she has this rope going over to the stack, holding on to her. She's not alone over there on the heap. Somebody always has control over her. And that's the thing, is so trying to explain that we are using the stack and as a way of controlling the lifetimes of all of our heap allocated memory, but also for any kind of other type of resource. And once you get used to it, it becomes a way of thinking, like it has become for all of us. And it's just something that you just start doing. Yeah, and then you have structure, because it's kind of different. Okay, so first, very simple. We split the class in two. In Java world, the what we call the header and the CPP file or CC file is one file. It's called .java. It's all in there. And so trying to say that, okay, we're putting all the declarations in the header file, we're putting all the definitions in the CPP file, and that's how we do things. Don't explain why. Just go with it. So you can explain that the header is similar to an interface, because they have interface, and it is-ish. And that's where you have the function declaration and the member variables. So then we get to classes and structs. So first of all, one thing that is kind of weird if you're coming from Java is that in Java, all objects are ultimately a subclass of the object class. They have one massive top node in their hierarchy of classes. And there's no such thing in C++. But still, we have implicitly defined member functions. And so you kind of have to explain that they are there and that they just come there by magic and you don't have to think about it. And I think that's a good place to start. Because remember, they're not newing anything. See? They're not newing anything. So they don't have to delete anything in their destructor because everything behaves good. And everything is nicely copyable because they're only using copyable types because everything is good because they are not newing anything. See? So I told you it was a good idea. So this is basically trying to explain that these things are, but then just drop all of the other rules, and we're going to go for rule of 0, which is a strange name for a rule which says that 0 except for 1, because you still need the construct. Why didn't they just say rule of 1? Just okay. Anyway, so we have to. This is the one slide where I'm going to show them. There are other things. There are even like. And here you have like you move assignment operator, and then you have the copy assignment operator, and I'm just going to skip over operators, because come on, okay, okay, give me each one of you like fingers. How many times in real life, in production code, not for fun, have you made an operator? not for fun.
When you write unit tests.
Especially move operators.
No, not move or copy assignment operators. I'm talking about like plus.
Yeah, or any geometric calculation.
Yes, but how many times have you written the operator?
One per
That's the thing. Okay, so don't go there.
I mean, for comparison, if you're putting something.
Yeah,
in fiction or
yeah,
whatever.
yeah. No, that's the equals and not equals. Yeah, those are more common. Okay, you got me on that one. Damn, those are more common. The thing is, it's like I really don't want to get into operators with these people, so I probably would skip for them for the. Okay, it'll go in lection 2. They can get operators in lection 2, because it's not something you do that often. Lection 20. Okay. Okay, they have a concept of, because this is also a weird thing, is where C++ and Java are opposites of each other. In Java, all methods in a class are virtual by default. In C++, this is the other way around, which is weird. So you kind of have to get used to it. But it is mappable. You just have to say it's the opposite, so it's all right. So you explain it by saying that in C++, all methods are final by default. And then it's like, okay, so but how do you do the whole virtual thing? And here, this is how I would explain it. I would say that if you want something like a Java interface, then you make a class with only pure virtual functions. It's the thing. It says the interface. It has no function. So it's very similar to a Java interface. Now, Java interfaces have gotten a little bit more fancy lately, but we'll skip over that. And that we have override, because Java has that too. and you should always use it. Okay. And then this whole multiple inheritance thing might get your Java programmers a little bit annoyed, because they were taught in school that that was like an absolutely unsurmountable problem. And just say that it works out. It's all right. Mostly because, okay, no, it's all right. It is all right, but we don't do it that much because it's generally, I think the whole industry got over the whole subclassing thing and came to applying interfaces is good, massive subclassing is bad. Some people have a lot of it still, especially in GUI-based things. It's like you have to have a widget, you have to subclass a widget, is kind of. But the thing is, they were made at the time when subclassing was cool, so it's very difficult to roll it back. But anyway, yeah. So if you're going to explain it, then a class by itself is abstract. The closest thing you have in Java for a C++ class is something they call an abstract class. And then you can just tweak it a little bit to fall into different categories. So if it only has pure virtual methods, it's sort of like an interface. If it has some pure virtual methods, you can call it an abstract class. Because in Java, an abstract class is not instantiable. And just a normal Java class has no pure virtual methods. Everything has to have an implementation. So it's kind of weird for them that we don't have an actual keyword to distinguish these cases. So you just kind of have to explain it in how the class looks. And then this is also a little bit hard. A struct is a class. Struct is a class. There's nothing fancy about it. You can have all of the other stuff in there. It's just that all the members are public by default. And just move on. Okay, and this is, yeah, okay. I don't know. It's like, it's sometimes, like, I've worked in projects where you feel like maybe the developer was docked like serious amount of money to make a new file, because they put everything in there and you have files that are like 10,000 lines long. But this is like a feeling like when they made like C and C++, they felt like we only have one keyword. We're going to use it for everything. This is a little bit difficult to explain, two people. So my best one is this. Anybody know where the quote is from? Oh, thank you. Thank you. There was only 5 of you. We're getting old, people. Anyway, there was a show in the 90s. They cut people's heads off. It was good. But if there's like a general like kind of mental model for it, there can be only one. And so some of them, they work normally. For a Java programmer, they also have the keyword static. And so if it is a member or a function, it is pretty much what you would expect if you're coming from Java. By the way, I put the slides on my Twitter. And my Twitter's on all of my slides here. So if you want the slides, you go to my Twitter. It's like the second tweet on my timeline. And it has a link to SlideShare. And you can download my slides. And for the other one as well. But anyway, yes. Then you have the static function in a CPP file. That is weird if you're coming from Java. What does that even mean? Okay, so how I explain it to people, the function is local to the file. There can be only one in this file or something. Okay, moving on. So then you have a static variable in a function, which is super weird. I basically say it's a global. It's a global. It lives inside of the function. That's its life. And anytime anybody comes in here, it's sitting around waiting for them to come back. We don't use it for much. Okay, that's my experience. Anybody here use function local static variables? In C. Yeah. In C++? One? Okay, what's your use case? Yeah.
We had a colleague, he used them like religion.
But you, did you have a use case? Yeah. Because that's yeah. That's the thing. Like the only case I've seen that was generally accepted was singleton type factory methods, or like instance methods, I mean. But the problem with those became after a while that people found them really hard to run memory checking on exit because, yeah. So, no. So it sort of became unfashionable again.
They are now.
So I'm not seeing it a lot anymore. But it is sometimes interesting, like while you're debugging, to do a little counter to see how many times you've been in a function. But you generally don't leave it there. But it's nice for people to understand that in this case you have a hero factory. It just returns a hero by value, and it counts how many heroes have been created, which can be interesting in some cases. Like some cases you want to count how many times new has been called. You might want to put something. Okay, and then containers and standard types. Now this is really hard because they have a string in Java, and it is pretty much well behaved, and it handles UTF-ness, and we if they ever had C++, they think strings in C++ is a car star. And so I think that this is like my back to the you never use pointers. This is the pointers, you don't use that either. It falls under that rule. But this goes specifically to don't use car star. And a lot of all of the things that I'm going through is basically to try to reduce the amount of errors that you will produce as a new Java programmer, and especially memory and security errors. And this is oftentimes in both those categories. Handling raw car star strings is generally really dangerous. So I say don't use it. Use std string, but most likely your project will have their own string class. How many have their own string class? Yeah. Sometimes there's an std string inside there. It's just that you put a lot of other fluff around, like some substring stuff and some utility functions, and then. But at least previously, it was very common to have your own a string class. But then you have string view. How many people use string view? Yeah, I think string view is really cool. Especially if you're coming from a C++ kind of point of view where you have a non-allocating immutable substring. I mean, this is like fabulous. This is performance-wise, I mean, okay. Look at string view. I think it's great. Okay. Okay, and then after having a long discussion on CPP lang with a bunch of really, really senior people, basically I said, okay, so if we're going to summarize this really, really long discussion into anything, it is STD vector is great and you should use it for everything. And the thing is, this is a little bit difficult to understand for people coming from Java because they only have containers that have pointers. They only have pointer containers. They have, like, if they have something that is similar to STD vector, sort of an API, which is called an array list. But the thing is, an array list has an array of pointers. So memory-wise, the performance is crap. And so trying to explain that STD vector is great is kind of difficult to understand, because especially because we were taught, how we were taught to program 15 years ago is not very applicable to today's architectures, because the cost of touching memory has become relatively really high. So we've been stuffing in all of these like caches in between us and memory to try to deal with that. And this is something that C++ can handle very well. But in Java, they don't have memory control. So for them, they have no idea where things are. But that's not their fault. They have no way of knowing, right? But the thing is, but if you have an array list, you have an array list of pointers to objects that are someplace in memory. And when you go to the next object, it's most likely going to be someplace that is not in anywhere close to your cache lines. So this is going to be massive cache misses all the time. This is something that is very difficult for a Java programmer to understand, because it's not something they have ever been able to control. So a lot of the algorithms that we were taught, that's saying like, okay, but here it's very easy because you only move this pointer over there, can become very slow on modern architectures, where it's actually better to just like stuff things close together and just go zhin, 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 zhin on this piece of memory because it's all in cache. Sometimes it can be faster just to copy things and stuff them together and do all your operations than it is to hop around all the time. So this whole concept of STD vector versus arrays, okay, first of all, don't use arrays, but you shouldn't be using arrays because you shouldn't have a pointer. Okay, so just skip over the no raw arrays. You're using STD vector or you're using some other type of data structure, but the thing is most other type of data structures don't have the memory performance gains of STD vector or similar types of containers. Okay, I'm going to skip over that. Sorry, I'm taking too long. Okay, and we have algorithms. This is to say again that we're not really old, and we have algorithms. You can do them. You can have like mappy stuff and map reduce stuff, and we're fashionable and cool, and we have auto. So don't say we're old. So basically, this is what we're trying to avoid, because this is where you're going to go if you're messing around with memory and you don't have control. So the whole talk is to keep yourself and your poor colleagues out of this problem and out of that problem. And that was the first presentation, so you can clap now.